Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction and a commentary to actually an older article about the practices that make continuous integration, written by my friend Thierry de Pauw. So it's an article that has been published in 2022, but is still, I believe, relevant for today. Only a few days ago, I had a question. I did a course with a group, and part of a group was manager leading a project, and she asked me about some of these practices, and this shows me that it's still not very clear how to use them. And when I saw that Thierry has reposted this article on social media, I thought, oh, well, maybe it's something we can dive back into and also give some commentary. So the practices that make continuous integration. Before we start, it's important to realize a few things, which I'm sure Thierry will touch upon. Continuous integration is confused by many teams with the tool that does continuous build, with the build server, right? Often it used to be Jenkins. Now I think it's more tools that are used for this. And it's really not that. Continuous integration is a practice. And the practice is that everything should work on the main branch all the time, right? So whenever you integrate something, is actually the practice of continuously integrating your changes into a stable thing, into a stable build. And you can do that in multiple ways. One of them is by having multiple branches and integrating, again, continuously. And okay, what do we mean by continuously? Because it won't be always, right? It has to be some time when you write the code, make sure that it works, and then you integrate it into the code line. And this, of course, what continuous integration is actually saying is that this time should be as short as possible, because if we do this, we get feedback faster. And if we get feedback faster, we can adapt faster and we can find issues faster and so on. And we can learn more faster. So that's fundamentally what continuous integration is. And one way you could do this is just to have one branch, and then you make changes, and those changes, when you push, they get integrated. You don't necessarily need to have a build server for that. Depending on how large the project is, you could have the main branch somewhere, and then you write code, then you integrate it, or you just write on the main branch. And when you are ready, you make sure that things are working. And how you do that, you run all the tests, and only if the test pass, then you push and integrate, right? So when we talk about integration, it can be as simple as a push to the source control. This is one way of integrating. Or it could be more complicated, like a separate branch that you work on, and then you integrate that branch. And there are a bunch of things that you can do around here. If you've seen my previous videos on this, Thierry is a big fan of pushing to the main branch, something called trunk-based development. And I believe that this is a trade-off. And I've explained at length that doing trunk-based development requires you to do some more things in code and influences your design in ways that maybe you don't necessarily want. Like maybe you'll need to introduce feature toggles. And okay, you don't have feature branches, but you have feature toggles, and those are more difficult to maintain and so on. So none of these things are actually free, but the general idea of continuous integration is extremely valuable, because by making sure at all times that your code base is stable and working is a big enablement. If you have this, you can then deliver very often, because you can basically decouple the development cycles from the delivery cycles, right? Like it happens with some of the tools. So for example, you can have, say, we have a delivery every week on Thursday, let's say, a Thursday at 3 p.m. Whatever is working is going into production on the production server. And that's one way to deal with that, right? And the development cycle, it doesn't matter. So whatever is ready in that window goes into production. Now, continuous integration is one or two steps removed from continuous delivery, which is a different thing, and continuous deployment. So we don't want to confuse these three concepts, because they are three very different things. Continuous delivery means that not only you integrate and things are working, but whenever there's something new, or at every 5 changes, or at a specific moment in time, things automatically go to the production server. So yeah, there are a lot of different ideas around this. And many teams are doing some form of continuous integration right now, but I'm not sure that they adopt all the practices that Thierry is describing here. And this is where I find it interesting to kind of review them and see how they fit into a developer cycle. So let's read a little bit through this article. Honestly, it feels a bit awkward to still write about continuous integration. It has been over 20 years since Ken Beck introduced continuous integration in his book Extreme Programming Explained, but when looking around me, I realized teams and organizations still struggle with adopting continuous integration. And then a quote from Jess Humble, who is the author of a book on continuous deployment or continuous delivery, I don't remember. Continuous integration is a practice to ensure always working software and to get feedback within a few minutes to whether any given change broke the application. Yeah, so this is what it is. Okay, it's a practice to ensure always working software. The purpose of continuous integration is to have always working software on mainline, allowing the team to perform on-demand production releases from mainline at any given moment in time. This is one of the most critical practices to adopt to enable the fast flow of work through the value stream and getting close to the single piece flow, similar to the manufacturing industry. As such, resulting in increased IT delivery throughput, better quality, and shorter time to market. We say a team is in a state of continuous integration when, and then another quote from Jess Humble, everyone in the team or every pair commits at least once a day to mainline, leading to multiple integrations per day for the whole team. Yeah, so, and it doesn't matter whether your commit is a merge of a branch or it's a push to the main line, these are relatively unimportant things. The important thing is that every day there's something new on the main line. Every commit to mainline triggers an automated build and execution of all automated tests, and whenever the build fails, the team is able to fix it within 10 minutes. Okay, now the last one. It's an interesting idea, but sometimes it's not that easy. I mean, I've worked with complex organizations who have complex infrastructure, and the fix is not as easy, but okay. Continuous integration is not a tooling problem. It is a state a team can attain by adopting a series of practices. Over the past 6 years, I had many discussions when talking about the myriads of problems introduced by the practice of feature branching. Yeah, and this is where we kind of diverge. I don't think feature branching has anything to do with continuous integration. I've done continuous integration very happily and productively with feature branches, so no, I don't see the problem. Many questions were asked on how to achieve trunk-based development, which is nothing else than true continuous integration. No. During those discussions, I was baffled by how little the practices that enable continuous integration are known. Most teams do not get beyond having a centralized build to then say they practice continuous integration. Surprisingly, very little literature is available summing up all the practices that make continuous integration. Most information is scattered over many books and articles. It led me to write this article series to summarize all the practices that make continuous integration in one place. Okay. And let's look at the practices. The first set is teamwork. Teamworking for continuous integration. The first part of this series, okay, practices that enable teamwork that in turn enable continuous integration. Continuous integration is a team practice. We achieve it as a team and not as a set of individuals. Most of the time, practices are defined for individuals. When most team members apply them, the team does well. However, with continuous integration, most team members have to implement other practices before the team can say they practice continuous integration. The difference between a tool and a practice is that a practice only exists when you are doing it. Steve Chapman, Tools versus Practices, Lessons Learned from DIY. Okay. Tools are very appealing to many engineers because often engineers hope by adopting a tool they get the practice for free, though again and again that is not true. Yeah, I've seen this bias again and again for developers. Tools are so important when in fact what I'm trying to teach people most of the time is practice, mindset. But we always have to discuss tools because you can't escape them. And they hope that just by using the tools they get mindset, but it's not that simple. On the other hand, the practice is the actual application or use of an idea, belief, or method. It is a codified way of working that might involve some tooling to achieve the practice, but generally no tooling is required. Yeah. Practice 1, version control everything. Yes. And by the way, you should version control your SQL code, if you have SQL code. And then the problem is if you are in a complex environment where you have things like custom ERPs or things like that, they have their own code that is written directly in the platform. Sometimes it's a configuration thing. The big problem with those is when you cannot source control the code that goes into them. That's a big issue. Hopefully most such tools have evolved and now you can do some kind of continuous integration, but these were the outliers for a long time. Continuous integration is a state we accomplish as a team, not as an individual. Therefore, to work as a team, we need something to coordinate production code, test code, application, and system configurations, database schema evolutions, infrastructure code, and many other things. Without version control, we do not have a single source of truth. Without version control, we may need a team and integrators to integrate the code before releasing it. If we do not version every single artifact required to create the software application, we will not enjoy any of the benefits of continuous integration. Yeah, I'm skimming through this because honestly, I think most people get it today, but I think most people have source control today. The bigger problem is to source control everything, including configuration, including infrastructure. So your Docker, your Kubernetes, your virtual machines, whatever you are using, that code has to be in source control as well. You should be able to recreate everything from scratch, from source control. Okay, that's the level we are talking about. Practice 2. Agree as a team to never break the build. Get everyone of the team to agree to the following. From now on, our code in revision control will always build successfully and pass its tests. James Shore, continuous integration on $1 a day. And by the way, it's worth reading James Shore's blog posts on continuous integration because he has some very good ideas about what it is and how to use it. Okay, so this practice is non-negotiable. There is no single acceptable reason that would allow breaking this agreement, even if production is burning. Nevertheless, it requires to run a local build, commit only on green, so when all your tests are passing, have a vast amount of high-quality automated tests, yes, have a fast build. Yeah. So these are all important things. We need to be able to run a local build. So when we still had problems with people who did not yet have the infrastructure for continuous integration, the first thing I would do is make sure that we can compile from command line locally, and then that we can compile from command line on a build server, and then that we can build everything else around it on a build server. So that's it. Yeah, so agree as a team to never break the build. I think now it's more or less accepted, but when I started as a programmer, it was very common to break the build. And because, so yeah, okay, let me tell you some stories. So we were using, I think it was Visual Source Safe as a source control at some point. And unlike Git, the way this would work is that you would lock files and then change them and then unlock them. And that's when you unlock them, you basically save the changes to the server. But this led to the following problem. Let's say you're a programmer, you get a task or something. Last day before holiday, you log some files, you leave, the build is broken, people cannot fix it. Now, fortunately, there were some ways to unlock, to force unlock, but you had to go to the admin and then you had to inform the developer that, we had to force unlock and make sure that your changes will not be overwritten and stuff like that. So it was a whole thing, which is why Git is great. Okay, after Visual Source Safe, which was basically an abomination, it saved data on a share in the network, which meant that it was easy to delete or to corrupt. I think the files would get corrupted often. It was a whole thing. And the next one was Subversion, which worked really well, but the time it took to make a branch was, I think it was linear with the code size. So it got really, really hard to branch. And then Git came and it solved all of these problems. So before complaining about Git, first of all, you don't need to use a lot of commands from Git, just a few. Second, the problem of source control is difficult, so this is why tools are complex. And third of all, you only need, you know, look at the history, because it was much, much worse. So we are in a very good place right now. Okay. Let's see. Practice 3. Do not push to a broken build. If the build happens to break, we stop the line and fix the build immediately. Yeah, and I think this is hard, particularly when you have multiple teams, large teams. It's getting a bit difficult to do that. But yes, it's better if you agree as a team to never break the build. And then when this happens, it might happen occasionally, particularly in the beginning. First of all, you need to have something responsible to fixing the build. And there are two ways you could do this by rotation, or they could be the person who pushed and broke the build, which I think is probably the best. And second, I think what you need to do is to learn from these mistakes and to see what you need to do differently. How sometimes when you first introduce the automated build, you need to work a little bit to debug it because there will be things that happen that you don't expect. And sometimes it's not the fault of the push and of the code. It could be the fault of the build script, because it doesn't have access to some files, or because it doesn't have enough space, stuff like that. So a lot of things can happen. Somebody needs to manage those and fix them. But in general, yeah, never break the build. So basically, before you push, you need to build, run all the tests, start the application, do kind of a smoke test, make sure that things are working, and that's it. In the beginning, when this started, when some companies introduced this, I remember them doing some weird things like connecting a siren to the build server, and the siren would start screaming when the build was broken, and so on. I think we are better now. The funny one was a team trained a robot. I think it was one of the Lego Mindstorms or something like that. But you could basically program it to go to the computer of the person who broke the build and say, "You broke the build. You broke the build." Now, of course, this didn't work perfectly all the time, because maybe they were away getting a coffee, but hey. Yeah, but in general, it's annoying for everybody when the build is broken. It stops everything, and you need to stop everything and fix it. Practice 4. Revert when broken. One of the preconditions of being in a state of continuous integration is to fix a broken build within 10 minutes. The longer it takes to fix the build, the longer we block the whole team. Given the salaries of IT engineers, there's quite a lot of money held in standstill. What is more, it disables on-demand production releases, consequently reduces IT delivery throughput and increases time to market. But why within 10 minutes? Because this is related to have a fast build. If the build is under 10 minutes, quickly fixing the problem and rerunning the build will work if the fix is easy. Honestly, for some languages, building fast is not that easy. So I agree with the principle. It's a good principle. We have to adapt sometimes. I'm thinking about C++. but also I think Haskell, Scala, I think had large build times. And yeah, you can definitely parallelize, add some more cores. Maybe it will make things faster, but I don't know. Okay, the next one, coding for continuous integration. Practice 5, make all changes in small increments. Break large changes into a series of small incremental changes that keep tests passing and do not break existing functionality. Well, so you see a lot of people, that's one of the challenges, I think. The general challenge for continuous integration, continuous delivery, agile in general, is learning incremental thinking. Incremental thinking, to me, is the ability to take a problem and to split it into smaller problems. And there are some mechanical ways to do this. There are some heuristics to do this. But the general principle is great, and we rarely applied it as developers because of different reasons, but I think one of them is because we were trained to think as we get a problem, we need to write the solution. And not in terms of we get a problem, let's split this problem into smaller problems and then fix the most important problem first. That's the next step. So this is a challenge. We prefer to have small incremental changes. It's much more challenging than it seems, and I think in my mind it correlates a lot with test-driven development, but not a lot of people, unfortunately, are doing test-driven development. If you do test-driven development, this will be a given. If you don't, then you have to force yourself somehow to do this, and it's not always obvious how. In Growing Object-Oriented Software Guided by Tests, Steve Freeman and Ned Price make this analogy with surgery. Surgeons prefer keyhole surgery over opening a patient's body because it is less invasive and cheaper. For the same reason, we prefer to work in small incremental steps because it is less invasive. We are not ripping apart the application, but therefore it is cheaper because we keep the application always working. We can perform on-demand production releases of the application at any given moment in time because the application is always releasable. Now, this is the point where there are some simplifications, I think, that a lot of people from the Agile community are guilty of, I would say. Even if all the tests pass and the build is working, does not necessarily mean that the application is releasable, because we often need, in complex organizations, we need security testing. And yes, some of it you can automate, but not all of it. And you might need some more things that you verify. And yes, we, in the Agile community, we do not like sign-offs. We like to remove them as much as possible. But in some environments that are more constrained, you just need to live with some of these things. And I wouldn't say that that's not continuous integration if the application is not releasable like immediately. And of course, we might understand that the application is releasable to say, okay, it's almost ready for release, but then we still need to do the release steps in order to release it. And part of the release steps will be a security test. But to me, that is a bit of a thing, of a misnomer, because honestly, the reason why we want to shift left a lot of these things and do them all the time or in the beginning things like builds, deployment, and so on, is because we want to avoid defects. And with security, we still haven't figured that out as well. You can do a bit of thread modeling, and you should do thread modeling. And this influences your implementation, and you can have automated security tests as part of your testing suite. But at some point, somebody will need to actually go and check. Sometimes for certification reasons, and sometimes just for safety and security reasons. So yeah, and you also need to have some exploratory testing anyway. So releasable may mean something else than people understand. Okay. Let's see, practice 6, commit frequently. The central premise of continuous integration is integrating early and often on mainline. This requires frequent commits into mainline. When not committing frequently, integrating code becomes time-consuming, vastly non-deterministic, and varies wildly in duration. As a consequence, this will slow down the IT delivery throughput and time to market. Yeah, and this is one of the arguments for trunk-based development, but honestly, I'm not buying it, because I can do the same thing by committing on a... I mean, if you work in Git, you have a local branch anyway, so you'll be committing on a local branch and then at some point integrating it, like once a day. You could do the same thing with a feature branch, where you develop on a feature branch and then you integrate it into the mainline once a day. It's exactly the same thing. So no problem there. You don't have to do trunk-based development in order to do that, but you can. So, okay, practice 7, commit only on green. To keep our application always working at any given time, we may only commit on green. This means we only commit when the local build says success, which also involves all tests being green. On the other hand, when committing on red, we violate one of the two paramount practices, agree as a team to never break the build. Yeah. This is where test-driven development supports continuous integration. We start by writing a failing test. We implement as little production code as required to get the test passing to green. When the tests are green, we commit into mainline, then we refactor. If the test is red, we revert. When the test is green again, we commit again into mainline. The steady decrease the commit cadence that satisfies commit frequently and that is required to accomplish a state of continuous integration. That said, even when not following test-driven development, it is possible and still vital to satisfy commit only on green, but we will have less confidence because we are moving forward in the dark. For sure, we will move slower. This is one of the things that many people don't understand about test suites. When you have a test suite that you can trust, and it dispels the doubts of programmers in time. They see that it works fine, they see that it catches things, catches regression and so on. One thing that happens is that people speed up because they don't think about all the possible things that might go wrong that are not necessarily related to their implementation. They know that there is a test suite that will capture things that they do wrong. If they make a mistake somewhere, they know that, and introduce a regression, there's a test suite that will capture that. Otherwise, developers tend to be really slow because they will think, okay, if I make this change here, this might happen, and okay, how do I check this? Or maybe let's not make this change. Maybe let's just copy paste this code from there here, because I don't know how it works and I need to modify a little bit, but it's not obvious. So there are a lot of things that could happen. And it's one of the subtle things about test suites. They help you speed up because you gain more trust in the system. And that's really difficult to achieve in other ways. Okay. Practice 8. Decouple the code base. To work in small increments, we definitely need a decoupled code base. When a code base is too coupled, it is arduous to adopt incremental software engineering skills. Any change will ripple through the whole code base, ripping apart the application, preventing the application from working all the time. Again, we incur sunk costs because we cannot release what we have already implemented for a long time. That is why adopting patterns like ports and adapters, together with simple design and intentional code duplication, are so important. These design principles help us in getting a decoupled code base. Consequently, this leads to a more maintainable code base and even more crucial, simple code that fits in our head. From my humble experience, having small classes, small methods, and applying the single responsibility principle together with dependency inversion principle. Dependency injection is a pattern. Thierry, I have to tell him that he has an error here. Together with dependency inversion principle already brings us a long way forward. Okay. Yeah, you need code that is easier to change, and using, there are basically, okay, there are multiple ways of doing this. Clean code with simple design is one of them. Ports and adapters, another one. Domain-driven design with some kind of service implementation. But basically, what we really need is modularity in the small, like small classes, small methods, small few variables, things like that. Few paths through the code, which is basically what clean code is about. And the second thing is we need modularity in the large, which is not a solved problem, unfortunately, yet. And my theory is that one of the reasons why so many organizations jumped on microservices is because microservices offer these modules with strong boundaries. And you can decouple things and kind of work on them separately. Unless you start coupling them again, like many organizations do. So yes. Practice 9, adopt expand contract. Expand contract seems to be a forgotten pattern in the IT industry. It is a little unknown gem, though it is unquestionably a strong enabler for continuous integration. We did a whole video on expand contract. Basically what it means is whenever you need to modify something, first you expand, basically you duplicate, then you make the modification, then you move the flow of code through that thing that you modified, test it, and then you remove the old thing. And this applies in the small and in the large, so it can apply for small refactorings. If you read through the techniques in the refactoring book by Martin Fowler, you'll find that this is the fundamental technique for many refactorings. And but also you can do this at higher level if you want to replace a module or things like that. It's also used for legacy code with the what it's called, the strangler fig pattern. So yeah. So expand contract. Expand contract works as follows. We start from a situation where the method is called at various places in the code base. Instead of changing the method signature and breaking the code base, we duplicate the method, apply the signature change to the duplicated method. We mark the old method as deprecated and we commit. This is the expand phase. Next, we gradually move consumers to use the new method signature. Once all consumers call the new method signature and the old method with the old signature is nowhere called anymore, we can remove the old method. This is called the contract phase. Yeah. It's a really powerful technique and you should master it and apply it at multiple levels. Practice 10. Hide unfinished functionality. Often features take a long time to implement. Most of the time it makes no sense to release a feature incrementally. For that reason, many teams use branch by version control to hide the unfinished functionality. That approach has the downside that we never integrate the feature with the rest of the code during its implementation. You see, this is where you're wrong. So the way you do feature branches correctly is that you integrate at least daily from the main line into your branch. And then you always are almost up to date with the main line. So no problem here. The features only gets integrated with the rest of the code base once we finish the feature and we merge the branch back into mainline. During the time the feature is being implemented, we are blend whether the feature causes any integration problems or not. No, we are not, because we can have exactly the same build system for the feature branch that we have for the main line. Now I'm starting to understand why people believe that the only way to do continuous integration is through trunk-based development. It's not, but you need to, once again, it's a practice. You need to practice continuous integration even when you have a branch, a feature branch. And the way you do that is you integrate the main line into the feature branch at least every day, if not more often, and you make sure that everything is working fine. It's as simple as that. Okay, instead of using branch by version control to keep unfinished functionality out of a release, we should just hide the unfinished functionality from the user. Hide unfinished functionality is probably the most straightforward practice to adopt. Not so sure. It is perfectly acceptable to have unfinished functionality sitting in production. It may even be behind a publicly accessible URL, as long as it is not discoverable by the users and cannot be misused by malicious act. So you see, you already are doing a lot of work because this goes against, I understand that I've done this, okay? But I wouldn't like to have a publicly accessible URL, because one of the rules and very good principles for security is to reduce the attack surface. If we add more URLs, we add more attack surface. And okay, you might believe that that does not lead to any problems, but attackers have all the time in the world, and you have bugs in the web server, you have bugs in your proxy server, you have bugs in your operating system, and you have no idea what a malicious actor might be able to do through a publicly accessible URL, even if that is apparently doesn't seem to do anything. So for reasons of security, I do not like this. I do not recommend this. One thing you can do, though, is to hide that URL with authentication. So add some authentication, and then yes. Although, well, you reduce the risk, okay? Reduce a lot of the risk, but not fully. So what I would have here is only special users can access this from a list. And that's it. But this means that you already are doing some extra work just because you have to have unfinished work in production. Yeah, not so sure. For instance, if we are developing a new user for our user interface, as long as we have not finished the screen, we do not add the menu entry to the navigation. We only add this at the end when the screen is completely done. We could say that adding the menu item is kind of flipping a toggle. That's true. Okay. But once again, because of security things, I would want that to be protected. it's fairly easy to scan URLs, okay? So, yeah, I think developers need to learn a little bit more about security. I've been trying to do my work around part of this. But one of the things that you realize fairly quickly is that what attackers are doing is not typing things very quickly, but they will run some tools for extended periods of time or from time to time automatically to do things like discover URLs or any kind of vulnerabilities. And when they get something flagged, then they can go on and investigate some more and run other set of tools and so on. So, no, I'm not that happy with that. The same is true for extending backends. If we are adding a new backend service, we do not add consumers as long as the backend is not yet finished. Or for adding new API endpoint, simply do not document the endpoint as long as the endpoint is not ready. Of course, this is not always possible. Sometimes we have to modify a widget inside an existing screen, or we have to change the behavior of an existing backend service. This is where feature toggles are required. Feature toggles give great flexibility. Toggles are enabled for operability and resilience, but be careful. Feature toggles can be extremely dangerous when done badly. It is tremendously easy to shoot yourself in the foot and introducing lots of technical debt with toggles. Yes. And this is why branching is actually easier. Because if you do feature branches, the only thing you need to do is to remember and to get this into the practice of developers to merge the main line into the feature branch and then to have the same build process as for the main line. That's it. If you do this thing, it's very easy to manage. If you do trunk-based development, then you have a bunch of things that you need to do that are extra work. Okay, your pick. Okay, so this is coding, let's say building. Building for continuous integration. Practice 11, automate the build. This is not about having a centralized build server. Yeah. You should be able to build your project from command line, from a script. Run one command, build everything. And that might include, creating images, installing packages, everything. Practice 12, run a local build. Yeah. You need to be able to get the changes, run a local build, make sure things are working. And if you have a script for that, it's easy. Practice 13, have a vast amount of high quality automated tests. If you do not have an automated test suite, the only information we get from running the build is whether the code compiles and whether a binary artifact was created for deployment. We do not receive any feedback on whether a change broke the application or not. Yes. So this should be self-explanatory. One thing I have to mention though is if you have an existing code base and you need to write tests for it, it's not enough to know unit testing. You also need to know how to write tests on existing code, which is the practices defined in Working Effectively with Legacy Code by Michael Feathers, and there are some other practices. So be aware that sometimes it's not enough to have the skills to write unit tests on code that is designed to allow unit tests, but you also need to understand how to safely change code that doesn't have tests towards having tests, enabling tests and then writing the test. So this is okay. When implementing automated tests, we should consider 3 types of tests. Unit tests, largest part of the automated test suites. We're speaking hundreds or thousands of them. They should run in less than 30 seconds. Each test should take milliseconds. They should not talk to the database file system over the network. A test that takes second is a red flag and requires immediate attention. Now this applies to backend code as well as front-end code, yes. Integration tests, they should test the adapters. This may hit the database file system and other system. They will take longer to run, so we want to limit this. Yeah, integration tests only test the integration between our code and external system. Automated acceptance tests, they test the application in isolation without third-party integration, but with a database and a front end as if it was a user using the application. Often these are implementing using behavior-driven development techniques. We should have hundreds of them. Their total execution time less than 10 minutes. The 10 minutes constraint nudges to make these tests efficient through test case isolation, parallelization, as well as improved code execution performance. And then they say smoke tests. And yeah, these are the testing pyramid and so on. Practice 14, have a fuzz build. If everyone in the team wants to commit multiple times per day into mainline, the local build has to be prompt. To prevent breaking the build, we need to execute this local build before committing into mainline. When the build is slow, two things may happen. Either people tend to not execute the local build before committing to mainline, or people tend to execute the build less often. So, but what is a fast build? 20 years ago, extreme programming suggested the build should take no longer than 10 minutes. They fairly advises in optimizing continuous delivery. We keep the commit build under 5 minutes. To conclude, 10 minutes is the limit. Everything under 5 minutes is better. 30 seconds is plain bonus for engineers, though some engineers have even higher standards. Yeah, so you need these fast builds indeed. And one way to do this is to have modularization. If you are able to split things into modules and then link to those modules as binaries, use the dependencies, then the build might move faster, although it depends because it's kind of cascaded. But this is one of the ways we deal with slow builds in C++. We build modules and then we refer modules by the binaries. And okay, it's not perfect. It's not rebuilding everything from scratch, but it's fast and it will find issues. And as long as you have some very clear rules, like when a new version changes, then you have to build the other things as well. Yeah, but you can get to pretty complicated scenarios the more applications grow. So pay attention to this. Sometimes you need to do some analysis for optimizing the build. It's not as easy. Okay, so what do we think? I think all of these are really good. But to me, rule 0 for everything related to agile, continuous integration, continuous delivery, everything is incremental thinking. This is the one skill set that you need to learn and that the whole team needs to learn, from the product manager, product owner, business analysts, developers, testers, security professionals. Everybody needs to learn incremental thinking. Operations, DevOps. No, everybody needs to know incremental thinking, which is fundamentally this. I get a large problem. How do I split it into smaller problems and select the most important problem to solve first? This is, in a nutshell, what we are doing with agile software development, from the product level all the way down to infrastructure and code. That's everything that you need to know. So if you master that thing and you apply it fractally everywhere, you are set. The rest is just a set of practices, well, more a set of habits, let's say. Things that you do, or a set of disciplines. we could also say. Things that you do because it's a discipline. And no matter if anybody is looking at you, you're doing the disciplined approach by applying incremental thinking first. And that, to me, in a nutshell, is the thing. So other than being not necessarily against, but seeing the other side of the story with trunk-based development, I think feature branches can work really well too. There's no big problem with feature branches, as big as some of the people in continuous deployment community want to tell us. Other than that, as usual, Thierry de Pauw, really great article, a good list of practices, a good list of things to do. And if you're not doing all of these things, then maybe you have something more to think about. That's it from me today. What do you think about all these things? Let us know in the comments. By the way, I plan to do finally some demos with nullable testing practices, and I had another question with dependency breaking techniques in C++. I plan to do those in the next few weeks. They will take a little bit to produce, so I'm not sure if it will be the next week, but these are answers to your comments that are long overdue, and I'm sorry for that, but there are a lot more things to do in the meantime. So yeah, let us know in the comments if you have any other questions, any other things that would like us to talk about, any other themes. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.